Hello students, greetings to each and every one of you watching this video. I remain your chemistry teacher, Borge23. Yeah, it's no news that due to the pandemic we have been locked down in our homes, and can't meet physically in school. But that doesn't stop learning. So in view to the ongoing pandemic, I brought up this innovation whereby we can be learning virtually. I just connect with you guys online. I share my videos on YouTube and then you guys watch it and then give me feedback. Sometimes we'll be using Zoom classes here where we can have an interactive session. I ask question, you ask question, I teach, you learn from me. So that's how we're going to be moving. So for the meantime, like I said, I remain your chemistry teacher, Budget 23. So for the meantime, we're going to start something. The essence of these virtual learning classes is to refresh your memory, to keep your memory intact. Most of us, there's how you stay at home a month, 2 months, or many more months, and then we forget everything we've been taught. So we're trying to keep our memory intact and then feel our wealth of knowledge. So we're going to start with something today. Starts on periodic table. We all know, or most of us have heard of, most of us have heard of periodic table, maybe from our siblings, our parents, grandparents, and the likes of them. So this is actually not the first time you have come across that word. Even if you are coming across this word for the first time, or these words for the first time, you have probably heard of the first 20 elements. Maybe the song, concerning hydrogen, helium, blah blah blah, and the likes of them. Maybe you have come across this song from your sibling. He has large brain but could not offer full 9 subjects. Michael Albert, stupid physics students, came after Professor Charles. Yes, most of us have different songs to which we tie this periodic table, or the elements in the periodic table, in order to remember. So, I'm just saying that majority have actually heard of the first 20 elements. Even if you don't know the element itself, you have heard of first 20 elements. Most of us have heard of the song attached to this first 20 elements. Most of us have also heard of the words periodic table. So it's my place to break things down. To give you a glimpse of what this periodic table is and what the 20 elements in the periodic table are. Why are they in the periodic table? What are the importance of this element, and how does this element affect our knowledge of chemistry? So this would be deliberated in the course of this tutorial. So I will implore you guys to listen attentively, as I'm going to use electronic slides here to add visuals. The periodic table will be displayed electronically and also will be shared from my end, so that you guys can see what I'm trying to talk about. And also you can use the comment section of this video to ask your questions, of which I'm going to give reply, or probably during our interactive session on Zoom we can kickstart. So what am I trying to say? Okay, so periodic table. What is the periodic table? Let's start from, let me start with this illustration. So periodic table is just like having a school. Let's just use our school as an example. Okay, let's just take this example. Yes, I'm going to be matching the periodic table to a classroom setting. Now let's just assume this is a classroom setting. We know that in a classroom there are desks. Yes, there are desks in each classroom. Let's say we have the rows and columns. We have this, we have this. Okay, we have these arrangements. We have 4 sitting arrangements. Yes, we have 4 sitting arrangements. We have the first column, the second column, the third column, and the fourth column. Yes, the first column, second column, third column, fourth column. That's the desk arrangement. Yes. Now we have, if you want to still match it, we have the horizontal rows. Now the first 4 students seated in these desks, yes, on a straight line, like this way. This is horizontal rows. Yes, we enter the next one, the second, 4 students seated on the second line, the second row. We have the tail row, we have a full row till infinity. Yes, just note that we have 4 columns. Yes, 4 columns. Their decks arranged sequentially from the first part of, like, let's say the entrance of the class to the end of the class. We have the second column arranged from the front of the class to the back of the class, the third column, the fourth column. All of them are arranged from the front of the class to the back of the class. Yes, so this arrangement, this vertical arrangement it's likened to the periodic table arrangement of elements. Yeah, while the horizontal arrangement, yes, the horizontal arrangement is also or is also relative. Yeah, it matches the arrangement of elements in the periodic table. How? Now, in the periodic table, let me show you guys. In the periodic table, we have elements. We have elements in the periodic table. Yes, it's just like in the classroom setting. We have students in the class. Now, in the periodic table, we have groups arranged in vertical column. We have groups arranged in vertical column. We have groups, if you can see, this is group 1, this is group 2, this is group 3, this is group 4. These are groups arranged in vertical column. It's just like a classroom. The class is arranged in 4 vertical columns, of which text follows after another. Yes, it comes after another. Yeah. Now, in the horizontal or in the vertical column arrangement in the classroom, we have horizontal rows. Yes, if you are moving, we have horizontal rows. That is line by line. This is vertical. This is vertical. This is vertical. The vertical column, and this is the horizontal row. So we are done with the column. The column is the groups. They say group 1, group 2, group 3. Yes, in the classroom setting. Yes, it's a vertical column arrangement in a classroom, just like this. We have the vertical column arrangement in the periodic table. All these arrangement, the vertical column arrangement is called groups. This is group 1, group 2, and the likes of them. Now the horizontal rows arrangement. This is period 1. It's called period. The horizontal rows is called period. This is period 1, period 2, period 3. Just like in a classroom setting, we have horizontal, we have row 1, we have row 2, we have row 3. That's the horizontal row sitting arrangement. So that is how it is classified. Yes. So periodic table is it's just like this. It's an arrangement of elements in their order of importance. The arrangement of elements in their order of importance. Yes. And this arrangement is based on the groups and periods to which these elements. Sometimes I usually tell my students that chemistry is basically life. Yes, some people say biology is the study of life, biology is blah blah blah, biology is this. Yes. Why do I say biology is life, like life itself? Yeah, it's because in the beginning God created chemistry. Yes, in the beginning God created chemistry. What do I mean? Now, we know that in the periodic table, yes, we have elements in the periodic table arranged in their order of importance in groups and periods. Yes. Now, these elements in the periodic table are actually real life examples. Yes, they are actually real examples of elements that we basically survive with. Let's just take, for example, the oxygen. We have oxygen in the periodic table. It is an element in chemistry. Yes, it is an element contained in the periodic table. So this oxygen, we breathe in oxygen and we breathe out carbon dioxide. Yes. So without the oxygen, we can't live. Not so. It's not possible to continue living without oxygen, because that's actually our breath of life. So that oxygen, that is a big part of chemistry. Yes, oxygen is an element in chemistry. Yes, that oxygen that is an element in chemistry forms the basics of life. Yes. So what do I mean by in the beginning God created the heaven and the earth? Oh, like in the beginning God created chemistry, not heaven and earth. Yes. What I mean is that most of us are actually familiar with in the beginning God created the heaven and the earth. Now let's take the earth for example. Yes, the earth actually comprises of some gases, some air, like we have gases that make up air. We have the nitrogen gas, we have oxygen, we have neon, we have hydrogen and the likes of them. Yeah. So these gases actually make up A. Like they are all components of A. Yes. And this A actually revolves around the earth to circulate life in different ways. The oxygen responsible for the survival of humans. We have the nitrogen and also oxygen, of which plants utilize the most in order to survive, in order to keep growing. We also have the hydrogen, which combines with oxygen to form water. Without the water, we can't actually survive. Just imagine staying 1 month without drinking water. It's not possible now. Yes, you'll be very, very much dehydrated, and that's a serious disease. Yes, so chemistry or water is a product of chemistry. The air we breathe in is a product of chemistry. So the earth in general, which God created in the beginning, is chemistry. Yes, the earth God created in the beginning is chemistry. Even the sun we do work on. The sun is a product of silicon and oxygen. Yes, it is a product of silicon and oxygen. Don't worry, I'm going to take you guys to into the aspect of chemical combination or the combination of elements to produce compounds and the likes of them. Yeah. So basically everything in nature are products of chemistry. Yes. The water we drink, the air we breathe, the plants, I'm telling you, the plants we see are products of chemistry. Yes, even the man-made things we see, they are products of chemistry, because in this we have states of matter. We have states of matter, which is solid, liquid, and gases, and chemistry deals mostly on the composition of matter. Yes, it deals mostly on the composition and the chemical composition of matter. Yeah, so that is just a preview on what the periodic table is. It houses elements that are necessary for not just for survival but for the usage of a lot of things. Yes, like the chlorine. You won't believe that chlorine is actually used in the preparation of salt and some other chemicals like that and the likes of them. So that's basically it. So there's this Russian scientist, Mendeleev. He was actually the first Russian scientist to discover the periodic table, and he saw that in this periodic table that there were some gaps, or there were some elements, yes, that are yet to fill these gaps. That there are some gaps, and also he discovered elements that can fill up these gaps. Yeah. So they actually introduced some elements into the periodic table to fit these gaps. Yes, to bring out the arrangement of these elements in their order of importance. And there is a law that governs that, which we have the periodic law, the modern periodic law, which says that the properties of an element are the periodic function of the atomic number. What do I mean? It's just like now, a student is in, or let's say a pupil is in kindergarten. Yes, a pupil is in kindergarten. If you have, okay, let's just take for example now, a child of 6 years is brought to you. Now you don't know the name of this child, you don't know the class of this child, and then from the physical appearance of this child, you are told to guess the age of the child and the class to which this child belongs. Sometimes it's somehow difficult because some people actually look small, but their age is something else. Yes, and some people actually look small and their class is on the high side. Now, on the balance scale, on a scale of 70%, a child of 6 years, let's assume you don't know the age of the child, is brought to you. There's no how you say that 6-year-old child is in SS3 or is a graduate. It's not actually possible from the look of that child. That's why I'm saying on a 70 on an 80% scale, it's actually impossible to say that a 6-year-old child, like you have seen, oh, this child looks very much young. He looks babyish, yes. And then he doesn't even have signs of, like, you haven't even seen any signs of physical puberty and the likes of them. Yeah, but you have seen the physical appearance of this child. He looks very small and let me just say childish, babyish, yes. And you just assume that the child is in SS3. You can't say that the child is in SS3 because the class is not, from the physical appearance of that child, you cannot just rate him to be in SS3 class. Yes. And you can't also rate him to be a 32-year-old child or a 32-year-old person. You cannot rate him to be a 32-year-old person because of the physical appearance of that child. You cannot rate that child to be a 32-year-old. It's not possible because of the physical appearance. You have rated the physical appearance of this child, and then you probably think of, let's say you don't know the age, you probably think of 8 years down or even 10 years down, because you cannot be above. Yes, 10 years down, because you know how a 6-year-old child will be. And like if a 6-year-old child is brought, yeah, the physical appearance, even the way he speaks will actually tell you that, oh, this is the age range of this child, even if you may not know the exact age of this child. Yeah, and also you also guess the class. You cannot say senior secondary or even junior secondary in some cases. Yes, you cannot say that because of how the child appears. So what am I trying to say? The modern periodic law states that the properties of elements in the periodic table are a periodic function of the atomic number. So the properties of elements in this periodic table, the properties of hydrogen, is actually a periodic function of its atomic number. It's just like let's say the physical appearance of a child who is actually it's actually a child or a product of primary 2 or primary 1 or even nursery. Yes, so that is what I'm trying to say. The classes is just likened to the atomic number. Yes, we have atomic number 1, 2, 3, 4, 5, 6. So they are arranged in their order of importance. So the properties of elements in the periodic table are actually a periodic function. Yes, it is a function of its atomic number. Hydrogen has atomic number 1. Lithium has atomic number 3. Yes. So if a student is brought to you, you say, this particular student belongs to this particular class because of his physical appearance, yes, and the likes of them. So the properties of hydrogen actually tells you the group it belongs and the atomic number it carries. Yes. So that is just it. The properties, the physical properties of hydrogen tells you which class hydrogen belongs. If it belongs to group 1, if it belongs to group 2, it belongs to group 3. If it is the first element in the periodic table, it tells you the physical properties of hydrogen, tells you which group or which period or what atomic number it is. So that is the scenario. That is how chemistry is. It's as simple as that. You can use anything to illustrate chemistry. It's as simple as it is. So that is just it. So the modern periodic law, take note. Yeah, this is sometimes a wire question. You'll be asked to state the modern periodic law. The modern periodic law states that the properties of elements in the periodic table are a periodic function of the atomic number. So if you want to explain, you want to expatiate, yeah, even you can just picture yourself, or picture a child being brought to you, and then you are told to rate the class of that child. Yeah, so you just know that the physical appearance of this child tells you what class the child is. So the physical properties of an element tells you the atomic number of that element, the group of that element. Yes. So that is just the modern periodic law. That is how it is sampled. Now, like I said, we have groups and periods in the periodic table. Yes, we have group 1, group 2, group 3. It's displayed on your screen, but meanwhile, I'm going to share it on mine for emphasis purpose. This is group 1, group 2, group 3, group 4, group 5, group 6, group 7, and group 8. We have 8 groups in the periodic table, and we have 7 periods. This is period 1, 2, 3, 4, 5, 6, 7. Yes, and we have blocks in the periodic table. We have blocks. This is the S block. This is the S block. This is the P block. This is the D block. And this is the F block. The S block, the P block, the D block, and the F block. It's just like saying this is junior secondary block, this is staff room block, this is senior secondary school block, and this is the administrative office block. Yes, so they are arranged in their order of importance. So this is the junior secondary, this is the staff room, this is the senior secondary school block, and this is the administrative office or other facilities. So that is how it is. We have 4 blocks in the periodic table, the SPD, the SPDF, yes, SPDF blocks, yes. And we have 7 groups, like I said. We have 8 groups rather, and 7 periods. Vertical column, horizontal rows. The vertical column is the group, the horizontal rows is the period. Don't forget. Yeah. So let's move into identification of these elements. Yes. Now, on your screen, you're actually going to see that we have the first. Normally, we usually quote the first 20 elements here for remembrance. In order to remember, we usually work with the first 20 elements. Yes. Yeah, because that's more like the basics. Yes. Until you get to the advanced level where you have to work with the first 40 and the likes of them. Yeah. So for the secondary level, we usually work with the first 20: hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, silicon, phosphorus, sulfur, chlorine, argon, potassium, and calcium. Yeah, so that's basically it. So this is the first element, hydrogen. This is the second element, helium. So you can say we can actually use the song. Yeah, he has large brain but could not offer full 9 subjects. He, hydrogen. He, hydrogen, has helium, large lithium, brain, beryllium, but boron, could, carbon, not, nitrogen, offer, oxygen, full, fluorine, 9, neon, subjects, sodium. He has large brain but could not offer full 9 subjects. Hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon, potassium, and calcium. So that's the first 20 elements. So I'm going to give you guys an assignment today, to work on or to know the first 20 elements offhand. Yes. So these numbers, yes, we have hydrogen as 1, we have oxygen as hydrogen as 1, we have helium as 2, we have lithium as 3, we have beryllium as 4, we have boron as 5. So these numbers are actually called atomic numbers. So if you ask what is the atomic number of hydrogen, it's 1. Atomic number of helium is 2. Atomic number of lithium is 3. Atomic number of beryllium is 4. Atomic number of boron is 5. So these are the atomic numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. They are atomic numbers. Yes, they are atomic numbers. Yeah, and that's just basically it. I'm going to teach you guys how to calculate the mass number, and how to calculate how to identify the groups and periods to which these elements belong in my next video. Yeah, so what you're going to do is just to subscribe to this video, subscribe to my channel, like, comment if you have any question. If you have any question that's bothering you from what we have discussed so far, don't forget to channel it in the comment section. Yeah, now subscribe to my channel so that you'll be receiving notification on our next class, though we'll be having some interactive sessions when it comes to calculations and the likes of them. I think the next class, which is the identification of groups and period, will involve more of calculations. Yeah, we need to use our pen and paper and then check some things. Yes, so we'll be using Zoom. We'll be using the Zoom application to enhance teaching. Yes, teaching of this particular subjects. It's still on that periodic table, but our next class will focus on how we can identify the groups and periods without looking at the periodic table. Because if you look at the periodic table now, you can actually identify that, oh, this is group 1, this is group 2, this is group 3, this is group 4, this is group 5, this is group 6, this is group 7, this is group 8. And they'll say, oh, which element is in group 2? You say it's beryllium because you have seen it in the periodic table. Which element is in group 3? Oh, boron. We have aluminium. Which element is in group 4? We have carbon. Oh, we have silicon. Oh, which element is in group? This is 3, 4, 5. Which element is in group 5? We have nitrogen, we have phosphorus. Oh, which element is in group 6? We have oxygen, we have sulfur. Oh, which element is in group 7? We have fluorine and we have chlorine. Oh, which element is in group 8? We have neon and argon. So with this periodic table, you can actually know the group and the period to which an elements belong. But how can you actually identify the group and period in the periodic table, of elements in the periodic table offhand? Yeah, I'm going to teach you guys to have it on your fingertips. Yeah, so that you even if you are not with your periodic table, of which you will not be in an examination hall, you'll be able to identify the groups and periods, because these questions are actually important questions, especially in JAM. They will ask you, the way they will twist the question, they may ask, oh, an element with atomic number 9 has or belong to the group dash. You have to find the group of the element that has atomic number 9. We know that, oh, 9 is fluorine. So which group does fluorine belong? And which period does it belong? So you will not use this in your examination. So how do you know, how can you identify the group and period to which fluorine, which is atomic number 9, belong? I'm going to teach you how to do that. It's actually simple. We'll still use the scenario of a classroom. Don't worry. Follow me, subscribe to my channel, and don't miss our next class so that you follow up. I'm trying to break down everything to you guys understanding. Yeah, if I want to teach professionally, you may not understand since this is a virtual class. Yeah, so I'm trying to break things down in a way that you guys will understand. Yeah, so that's basically it. Thank you very much. I remember Boshe 23, your chemistry teacher. Goodbye and God.